I'll explain it later. Sorry.
I'll just explain.
So good thing I looked.
Yeah, you like gave it a look, and all of a sudden I was like, I never hit record again. Sorry.
Abby
Okay.
saved the day.
So we're going to go to example 3 now, which is asking you. They're telling you the domain. What does domain mean again? It's the x values. So they're giving you the domain. So they're giving you x values. They're saying 1, 3, 5, 7. You're putting in for your x. They want you to find the range, which means you're going to find the y values that go with it. And I see Maddie just made a quick table, and it's a great way to do it to be able to organize your information. That she just puts those x values in and figure out the y from there.
Come on.
No, it's throwing stuff around.
Oh.
Sorry, online students. All right. So again, if you'd like to just make a little table, or I can't make the table like the right size that way, so I'm gonna go this way. And so I'm trying to find the y values, which is the range based off those x values. So just like our warm-up, we're putting each of those values in and finding the y values. So 4 times 1 minus 12 is negative 8. 4 times 3 minus 12, 0. It'll be 16. And you might even notice a pattern there. A lot of times in these linear equations, or similar to our quadratics, there are patterns. So that's okay to notice those and realize that happens. Okay, this last question. So make sure you guys follow along with me, because this is kind of where the idea of domain and range is actually kind of useful and maybe a little bit applicable. So it says you have 7 quarts of paint to paint the trim in your house. So like little buckets of paint, 7 quarts. A quart of paint can cover 100 square feet. So usually on the little bucket, it'll tell you how much it can cover, so you're not buying like crazy amounts of paint for your house. The formula is area, quarts, equals 100 cubes. So every time you use a quart, you're painting 100 square feet. So what's the domain? What domain and range are reasonable for the function? So first of all, which one goes with the domain? Which variable would be our kind of our x in this case? What's that? I can't hear you. Which variable? So which there's Q and A. Which one is going to be like our x? Which one can we choose? Q. We can choose how many quarts we buy. So Q is going to be our domain. And then that means our range is going to be our area. What values for Q make sense in this problem? Should I pick negative values? No, why not?
You can't get negative quarts of
Yeah, I
paint.
can't buy negative quarts of paint. So Q being negative doesn't make sense. Could Q be 0? Can I decide to buy no paint? Yeah, so actually Q being 0 is actually not the worst idea. Like maybe I just don't do it. So 0. Is there a limit? Can I have 5,000 quarts of paint in this problem? You see? I go up to 7. I don't want to go beyond 7 because that's all I have. So I could choose to not paint at all, or I could choose to use all the paint up to 7. You can like kind of just. So the domain is basically 0 through 7. Now my range is based off of how much paint I have and how much I can actually paint. And that's going to be the A value. So what am I doing to find A? What does our equation tell us? What's our equation telling us? How do we find our A? So what happens if I don't paint at all? What's my area that gets painted? 0. What happens if I use 1 quart of paint? How much is getting painted? There's an equation up there, you guys.
100.
100. It's 100 cubed. So I'm taking these cues and putting them into that equation. So if I paint, or I use 1 quart of paint, I'd paint 100 square feet. And if I had 2 quarts, I'd have 200 square feet. If I had 7 quarts, how much would I paint?
700.
700. Why are these numbers helpful for my graph? Why would this be useful for my graph? Yeah, that tells me my x and y axis. Don't draw this. But so we're so used to drawing a graph that way. Is that even useful in this case?
No.
No, because I don't care about the negatives because I'm not going to paint negative rooms in my house. Like that doesn't even make sense. So it helps me to set up my graph in a way that makes sense. So the domain and range is pretty applicable, like in terms of it's reasonable values. Like if you went into a business meeting someday and was like, what happens if negative people show up for our show? I mean, I'd hope they'd be like, what are you talking about? Like there's a reasonable value that makes sense. So we're gonna make our graph here. And the x value typically goes across the bottom, so that's near quarts. And then our area will go up the side. But I can make a reasonable range here. So I want basically 1 through 7 or 0 through 7 across the bottom. I don't know if I have enough space to skip. Oh yeah, perfect. So there's 7 quarts. Here's 1, all the ones in between. The area, same thing. I start at 0, go up by hundreds. I have enough that way too. I don't know if it's actually square. 2, 3, 4, 5, 6, 7. Oh good, look at that. And so the graph would just be a linear function. If I don't paint at all, if I have 0 quarts, if I have 1 quart, it's 100. All the way up to 7 quarts is 700. This is a linear function. But again, that domain and range is super useful because it makes sense for this problem. I don't need to worry about what happens when it's negative or when the area is negative. Like that doesn't make any sense for this problem. Okay? So you guys have the rest of the time to work on your homework. The homework that's listed there, I do not believe you need any graph paper. I don't think it actually makes you graph anything. If you do, you can always just sketch it. Otherwise, I do have graph paper here. Like if you look ahead and notice you need some. My answer key, I don't think had any, so.
Goodbye. Have a good weekend.
See you soon. Maybe.